Dear students, this session is started with restricted circular permutations. Before that, we have to see one result. The number of circular permutations of n different things taken or at a time is n minus 1 factorial if clockwise and anti-clockwise orders are taken as different. If it is not taken as different, we discussed in the previous class n minus 1 factorial by 2. Here just n minus 1 factorial. For this topic, case 1. If clockwise and anti-clockwise orders are taken as different, then the number of circular permutations of n different things taken or at a time equal to npr by r, that is 1 by r into n factorial by n minus r factorial. Example, in how many ways can %24 be seated round a table if there are 13 sets. Solution. The required number of circular permutations NPR by R, that is R takes only 13, 24 factorial by 24 minus 13 factorial 1 by 13, 24 factorial by 11 factorial. Find the number of ways. Three Americans, two British, one Chinese, one Dutch, and one Egyptian, can sit on a round table so that persons on the same nationality are separated. Totally, we have 9 persons. The total number of is without any restriction is, that is n of u, n minus 1 factorial, 9 minus 1 factorial equal to 8 factorial. Sorry, we have totally 8 members. 8 minus 1 factorial, that is 7 factorial. 7 into 6 factorial. 7 into 6 factorial means 5 factorial, that is 120. 120 into 6, 720. So 5040. So n of u equal to 5040. When three Americans A1, A2, A3 together n of A totally 8 A1, A2, A3, British B1, B2, Chinese C1, one Dutch D1 and one Egyptian 8-1, 3, 5, 6, 7, 8. You can consider this one as 1 unit. So 1, 2, 3, 4, 5, 6. So 6 minus 1 factorial into they can be arranged among themselves in 3 factorial ways. That is 5 factorial into 3 factorial. 120 into 3. 360. 3 factorial means 6. Sorry. 720. So n of A equal to 720. Next case, when two British people, that is B1, B2 sit together. So you combine this as a 1 unit. 1, 2, 3, 4, 5, 6, 7 units. N of B equal to 7 minus 1 factorial into two British can be arranged themselves 2 factorial. That is 6 factorial into 2 factorial. 720 into 2. So n of B equal to 1440. When 3 Americans A1, A2, A3 and 2 British B1, B2 sit together, n of A intersection B. These 5 people sit together. So 1, 2, 3, 4 units. 4 minus 1 factorial you can consider this 1 unit, this 1 unit, C1, D1, E1, they sit together. So 5 units. So 5 minus 1 factorial. 3 Americans can be arranged themselves in 3 factorial into 2 factorial. 4 factorial into 6 into 2. 24 into 6 into 2. 144 into 2. 288. So n of A intersection B equal to 288. N of A union B. N of A plus N of B minus N of A intersection B. 720 plus 2160 minus 288. So 1872. We need n of A dash intersection B dash, that is n of U minus n of A union B. N of U 5040 minus 1872. So 3168. Twenty persons were invited to a party. In how many ways can they and the host be seated at a circular table. In how many of these ways two particular persons be seated on either side of the host. Total number of persons 21, that is 20 persons invited and host 1. The number of the total number of ways, that is n minus n factorial, 21 minus 1 factorial equal to 20 factorial. This is case 1, first part. Case 2, two specific persons are seated either side of the host. So host plus 2 persons you can consider them host plus 2 persons equal to 1 unit. Total we have 21. So here 3 persons, remaining persons 8 units. Total 19 units. Hence, the total number of ways sitting 21 persons on the circle table such that two particular persons be seated on either side of the host equal to 19 minus 1 factorial and two persons can be arrange themselves into 2 factorial. That is 18 factorial into 2. So result, if clockwise and anti-clockwise orders or thickness not different, then number of circular permutations of n different things taken or at a time equal to npr by 2r. That is 1 by 2r into n factorial by n minus r factorial. Example, how many likeness of 12 beads each can be made from 18 beads of various colors. The required number of equal to npr by 2r. 2 into r, that is 12. 18p 12. 1 by 24. 18 factorial by 6 factorial. 18 minus 12, 6 factorial. Next concept, combination. Each of the different groups or selections which can be made by some or all of a number of given things without reference to the order of things. In each group is called a combination. In permutation, the order is important. In combinations, the order is not important. The number of combinations of n different things taken or at a time is denoted by NCR or C of n comma r on this notation. That is also the used to denote combination NCR. So NCR equal to n factorial by r factorial into, this is the formula, NCR equal to n factorial by r factorial into n minus r factorial, which is also equal to NPR by r factorial. NCR is a natural number. NCR equal to 0 if R is greater than n. NC naught equal to NCN equal to 1 and NC1 equal to n. NPR equal to NCR. This is possible if R equal to 0 or R equal to 1. NCR equal to NC n minus R if R is greater than n by 2. If NCX equal to NCY, which implies X equal to Y or X plus Y equal to N. NCR plus NC R minus 1 equal to n plus 1 CR. NCR equal to n by R, n minus 1 C, R minus 1. n అంటే n minus 1 C R minus 1 equal to n minus R plus 1 into NC R minus 1. n into n minus 1 C R minus 1 equal to n minus R plus 1 into NC R minus 1. NCR by NC R minus 1 equal to n minus R plus 1 by R. If n is even, NCR is greatest for R equal to n by 2. If n is odd, for R equal to n minus 1 by 2 or R equal to n plus 1 by 2. NC naught, NC1, NC2 up to NCN equal to 2 power n. NC0 plus NC2 plus NC4, that is even, that is equal to odd, NC1 plus NC3 plus NC5 plus etc. equal to 2 power n minus 1. Two n plus 1 C dot, 2n plus 1 C1, 2n plus 1 C2 plus etc. 2n plus 1 Cn equal to 2 per 2n. NC1 n plus 1 C n plus 1 Cn n plus 2 Cn n plus 3 Cn plus etc. Two n minus 1 Cn. Two n C n plus 1. "36 games were played in a football tournament with each team playing once against each other. How many teams were there? let number of teams be n. So NCT equal to 36. Total teams, total number of games 36. We can write as 72 by 2. That is 9 into 8 by 2. 1 into 2. That is 9C2. So NCT equal to 9C2. Therefore, N equal to 9. So want to find 5C2 means we can write 5 into 4 by 1 and 2. That is 10. 100C2. 100 factorial by 2 factorial into 100 minus 2 factorial. That is 100 factorial by, so NCR equal to n factorial by n minus r factorial into r factorial. We have applied this. 2 into 98 factorial. 100 into 99 into 98 factorial by 2 into 98 factorial. This will be cancelled. That is 100 into 99 by, if you have 2 factorial, that is 100 into 99 by 1 into 2. This is the way to simplify. So instead of writing these steps, 100 C2 equal, simply you can write 100 into 99 by, you can easily remember. Suppose 50 C3 you want to find. You reduce 3 times, 50 into 49 into 48, here 3 into 2 into 1. This is the way. The reason behind this, we note NCR equal to NPR by R factorial. Suppose 100 CT means 100 P2 by 2 factorial. 100 P2 means 100 into 99. 2 factorial means 2 into 1. This is the reason behind that. So in this method, you can calculate the value of combination results easily. So restricted combinations. The number of selections or objects of n different objects when k particular things are always included. n minus k c r minus k. K particular things are never included n minus k c r. The number of combinations of odd things out of n different things such that k particular things are not together in any selection equal to NCR minus n minus k c r minus k. The number of combinations of n different objects taking or at a time when p particular objects are always included and q particular objects are always excluded equal to n minus p minus q c r minus p. Note. The number of selections of or considered things out of n things in a row, that is n minus r plus 1. The number of selections of all consecutive things out of n things along a circle that is n if r is less than n, that is 1 if r equal to n. So we will discuss more concept next session. Thank you.